Hello everyone, welcome to another video. In today's video, I will be talking about AWS's Elastic Load Balancing Service or AWS ELB. Okay, so I'll be talking about some theoretical concepts around it, and then I'm going to show you a hands-on demonstration of how to create a load balancer and how to use it with your virtual machines, which is hosting some web applications. All right, so let's talk about a very general concept about what is a load balancer in general. So if you see the diagram right now on the screen, so here I have two virtual machines or two EC2 instances. Okay, so I have created two EC2 instances in my AWS account, and these two EC2 instances are part of auto scaling groups. If you have not watched my last two videos on auto scaling group, you can do so. So you can watch those videos to understand all the concepts around auto scaling group. Okay, and then you can come back to this video. So in this way, you'll be able to relate better. Anyways, so here I have created two EC2 instances in my AWS account, and just imagine that these two instances have a web application running on them. Okay, now why do we need a load balancer? We need a load balancer to balance the load. Pretty simple. So just that, the name itself suggests load balancing means we want to balance the load. Now the meaning of this load is user load. If you see, the users who are trying to access your applications, okay, on multiple instances or multiple these virtual machines or EC2 instances, you want to balance the load on each of these servers so that one server does not have any issues or does not crash. Okay, so we want to balance the load from the users that is coming into your applications hosted on your virtual machines. Okay, so for that we need a load balancer. Okay, so that's what it does in general. Okay, but a load balancer can also be used to perform health checks on your virtual machines, or it is also called targets. Okay, in terms of AWS's load balancer service, that is called AWS ELB. We also call these instances which are running behind your Elastic Load Balancing service as targets. Okay, so a load balancer is used to balance the load which is coming from your end users to access the applications, and also it can perform health checks on the target machines or on the target instances. Okay, if the health check is passed, only then the load balancer is going to pass on the user traffic to that service. If the health check fails, in that case, it is not going to pass on the request to that particular instance or virtual machine. So in this way, it is also helping us to have some fault tolerance in our application infrastructure. Remember this. Okay, so a load balancer balances the load. It can also perform health checks on the target machines or on the target instances which are running behind it. Also, it can help us with the fault tolerance of our application architecture. Okay, because if the instance health check failed, then it is not going to pass on the request from the user to that particular server. It is only going to pass the request to the healthy servers, the servers which have passed the health check. Okay, so this is a very general concept of a load balancer. Okay, now let's talk about what is AWS's Elastic Load Balancing. Okay, so an ELB or Elastic Load Balancer is a resource that automatically distributes your incoming traffic across multiple targets, which we already just saw in the diagram. The targets can be EC2 instances, it can be containers. Okay, I took the example of EC2 instances, but a load balancer can also balance the load from the multiple containers, or it can be a group of IP addresses also. Okay, it depends on the use case or on the type of application that you are dealing with. And also it does it in one or more availability zones. So let's just go back to our diagram. Here if you see, I am using this AZ1 and AZ2 because whenever you create a virtual machine, or an EC2 instance in an AWS account, it is always created in an availability zone. Okay, so here I've taken an example of two different availability zones where I've created two different EC2 machines. So a load balancer can balance the load across one or more availability zones. Okay, so that's what it's written here also. Okay, then it also monitors the health of its registered targets, as we just saw. Okay, and routes traffic only to the healthy targets. Elastic load balancing scales your load balancer capacity automatically in response to changes in incoming traffic. It means that an elastic load balancer, once created in your AWS account, it is completely managed by AWS to scale itself, which means that if the load on the load balancer increases, it is the responsibility of AWS to scale its capacities to match the increased user load. So we don't have to worry about it. Okay, so it's a highly available, highly scalable service which is fully managed by AWS. Okay, I hope the concepts related to a load balancer in general is clear now. If you still have doubts, please reach out to me in comment section. All right, now what are the benefits of a load balancer? So a load balancer distributes workloads across multiple compute resources, as we just saw, such as virtual servers. Then using a load balancer increases the availability and fault tolerance of your applications. Okay, that I just showed you that since a load balancer performs health check on its registered targets, so it's going to see if the instance or the target is healthy or not. Only then it is going to forward the traffic to that instance, else it will not. So you're able to achieve a fault tolerance for your applications as well using a load balancer or using an elastic load balancer in AWS. So the meaning of this elastic word itself, elastic means it is elastic in nature. It can it can stretch itself when needed. So okay, so any word that you see in AWS that starts with elastic, it means that it can scale itself. Elastic means it can scale itself. Okay, so all the services with elastic word means it can scale. All right. So now other benefits, you can add and remove compute resources from your load balancer as your needs change without disrupting the overall flow of requests to your applications. The meaning of this is, if I go back to this diagram, in future, if I have any requirement wherein I want to remove one instance and add another one, so I can do so without impacting the users at all. Okay, so I'm able to add or remove these instances that are running behind this elastic load balancer without having any impact on my end users. Okay, so this is one of the benefits of a load balancer. Okay, then you can configure health checks. We all know now that we can configure health checks on load balancer. So that's also one of the benefits, which can monitor the health of the compute resource in general, right? So that the load balancer sends requests only to the healthy ones. So this is the default behavior of a load balancer, that it is only going to send the request to the healthy nodes or healthy instances and not to the unhealthy ones. You can also offload the work of encryption and decryption to your load balancer so that your compute resources can focus on their main work. The meaning of this is, in general, if we talk about an elastic load balancer can also be attached with the certificates, with SSL certificates in general. Okay, if I talk about application load balancer, so we can attach an SSL certificate to it so that we don't have to do it on the instance level or on the machine level. So if we attach one SSL certificate to this load balancer here, so in that case we don't have to attach any other certificates to our target machines. Okay, so this is again one of the benefits. Then we have 4 types of elastic load balancers in AWS. Okay, and I'm going to talk about all of these, okay, in some detail, and then I'm going to show you a demo of the application load balancer. That is like the most used load balancer if we talk about DevOps based container applications. So you'll be using application load balancer the most. Okay, but we also use this network load balancer also. Okay, and this gateway load balancer, I still haven't used it, frankly speaking, but I have gone through the documentation around it, so I'm going to give you some information around it. Okay, but I have never used it myself. And this classic one is like the what do you call, previous generation load balancer that is not used anymore. Okay, only in some rarest of cases I think you'll be using it nowadays. So I mean, it was being used in the past, but now we are no longer using it. So we mainly use application and the network load balancer the most, and then in some situations we can use this gateway because it has its own a unique reason. So I mean, we can use this gateway also, and we will rarely use this classic one. All right, so let's start with application load balancer first. ALB, it's also called ALB, application load balancer. So a load balancer, when you're creating a load balancer, you have to create another resource within the load balancer that is called a listener. A listener checks for connection requests from the clients using the protocol and port that you configure. Each listener has rules to route traffic to its registered targets. The meaning of this is, when you are creating application load balancer, you get the option to create a listener, and within the listener you choose the protocol and port that you want to use with the load balancer. Okay, I'm going to show you a demo also, but just remember this part, that within a listener we create the protocol and port. I mean, we choose the protocol and the port to which the request will be forwarded from the load balancer to the target machines, and you also get to create the rules where to route the traffic and in what circumstances or conditions. So you have all the options within application load balancer. Now let's talk about the target group. A target group routes requests to registered targets on port protocol that you choose in your listener, right? So the meaning of this target group is the group of targets. So if I take this example, so this instance and this instance can be a target group. Okay, so like a group of instances, you can say. Okay, so a target group routes requests to the registered targets on port protocol that you choose. Then health checks are performed on all targets registered to a target group. Okay, it's obvious now. Then what are the features of an application load balancer? This load balancer is based on OSI. So if you have not watched my video, I've created one video on OSI networking concept. Okay, so you can go and watch that video. Okay, so within that OSI layer, the different layers of OSI model, you have layer 7, which is called application layer. So this load balancer has the features of layer 7 of the OSI model, which means it's a load balancer which is based on layer 7. Okay, it uses this routing algorithm which is called round robin. Now the meaning of this is so each load balancer that you create in AWS has its own routing algorithm, which means that there are different ways by which the request can be routed to the target machines. Okay, so that a method of doing it, it's called a routing algorithm. So each ALB or each load balancer has its own routing algorithm. In case of application load balancer, it is called round robin. Round robin means if you get 2 requests, okay, so one request will be sent to this, the other request will be sent to this. Okay, given these 2 are healthy, only in that case. So 1, 2, 1, 2, like this. So I mean, one by one, these different targets are going to receive the request from the load balancer. Okay, so this is called round robin way of sending the request to the targets. Okay, so that is the default algorithm here for application load balancer. but it can be changed to another one that is called least outstanding requests routing algorithm. So the target machine which has least outstanding requests, which is free to use, so that will get the request first, the meaning of this type of algorithm. Okay, so we have both these algorithms with our application load balancer, but this is the default one, round robin. Okay, so remember this because it is asked in the interviews a lot. The different features of an application load balancer. So just tell them that it is based on layer 7 of the OSI model. It is called application layer. The default algorithm is called round robin, and you know now about the meaning of round robin, but you can change the algorithm to least outstanding requests as well. Okay, also it supports path-based and host-based routing. Now what is the meaning of this path-based? I've given some example like /kids/footwear. Suppose you have an e-commerce website, okay, where you sell, it's an online clothing store, for example. Okay, so within that clothing store, you will have different catalogs of items or products, right? For example, there's one section for kids. Okay, so you can you can do some path-based routing using an application load balancer. For example, you have some separate items for kids, so you can add this path to your website, okay, and the request will be forwarded only to that section which has the kids items. Okay, so this can be done using this path-based algorithm which is available with your application load balancer. Okay, similarly, if you have something related to footwear only, in that case you can use a path like /footwear. So if the user is entering this path along with the website, okay, then the request will be forwarded to /footwear section only. So this is called path-based routing, and it is one of the most important features in an application load balancer. Okay, similarly, if you have multiple subdomains available, then you can use host-based routing. So host-based routing and path-based routing both are available with application load balancers. Then it also supports multiple target types. Okay, as we already know that it supports EC2 instances. Okay, but it also supports IP addresses. So when I say IP addresses, I mean suppose you are having an application that is deployed as ECS task, which is nothing but a Docker container in the backend, or it's like a container running. So it's called task in terms of ECS. So if you have some group of ECS tasks running, so you can use this application load balancer to balance the load on your ECS tasks or containers. So this is one of the other features of application load balancer. All right. So once again, if you go through the official documentation on ELB from AWS, so it is a huge documentation. So when you have time, please go through it, because all the things cannot be covered in one video. But whatever was the most important points, I've just made on this note of it here. Okay, and this is pretty important from interview point of view. So just remember this, that all these things are important for you to understand and learn, okay, before an interview. All right, next is network load balancer. So an NLB or a network load balancer also has a listener that checks for connection requests from clients using the protocol and port that you configure, and it is able to forward the request to a target group. Then a network load balancer target group supports TCP, UDP, TCP_UDP and TLS protocols. Okay, so these are the protocols that it supports. You can register a target with multiple target groups, okay, as is with our application load balancer as well. You can configure health checks on a per target group basis. So that can be done as well. Then health checks are performed on all registered targets. Okay, that is specified in your listener rule for your load balancer. Okay, so this slight difference between NLB and ALB, okay, because it only supports these protocols. Okay, But some things are common, like it also uses a listener that has this protocol and port, this configuration. It also has a target group, and it is also able to perform health checks. Okay, but it differs a lot in terms of features as compared to ALB. Okay, so the features of NLB is, it is based on layer 4 of the OSI model, which is called transport layer. It can handle millions of requests per second. Now, this is one of the interview questions as well. Suppose you have an application that that needs to handle millions of requests per second. So, which load balancer will suit the most? The answer is this network load balancer and not the application load balancer. Okay. So, an NLB or network load balancer can handle millions of requests per second. It is based on OSI model layer 4, which is the transport layer. Then when you enable an availability zone for the load balancer, okay, elastic load balancing creates a load balancer node in the availability zone. So, so it means is that whenever you create an NLB in any availability zone, so it's going to create its own node in that availability zone for you to use. Okay, I mean we don't create it manually, but when you create a load balancer, it creates it itself. Okay, so that's how it functions. So by default, each load balancer node will distribute the traffic across registered targets in its availability zone only. So this is the default behavior. Okay, the default behavior is, if you have created one load balancer in a particular availability zone, then one node will be created there and the traffic will be served only in that availability zone. This is the default behavior. But you have the option of choosing a cross zone load balancing. Cross zone load balancing means that each load balancer node distributes traffic across registered targets in all availability zones. So if you enable this feature, then one node which is in one availability zone can handle or can serve traffic in other availability zones also. Okay, so it will depend on your use case, on your requirement, that if you want to enable this cross zone load balancing or not. But this is not the default behavior. Okay. Then for TCP and UDP traffic, the load balancer selects a target using a flow hash algorithm. So if you remember ALB has the round robin default algorithm, and you can change it to least outstanding requests. But in case of NLB, the default algorithm is flow hash algorithm. This algorithm is based on a protocol, source IP address, source port, destination IP address, then destination port and TCP sequence number. So this algorithm checks all these things, okay, before it it forwards the request to a target. So, okay, so it is called flow hash algorithm. Next, elastic load balancing creates a network interface for each availability zone you enable. Okay, each load balancer node in the availability zone uses this network interface to get a static IP address. So this is again another feature or another interview question. If you have a requirement wherein you need to have one static IP address, in that case, you have to use a network load balancer. Okay, so for a static IP address requirement, use NLB. Okay, so I mean all it means is that in each availability zone that is being used with this load balancer, it's going to create a network interface or an ENI, elastic network interface. Okay, and this ENI will have a static IP address. So that's why it is able to maintain a static IP address. Okay, so if you have a requirement of this static IP address, then use NLB. Then it also supports EC2 instances and AWS ECS tasks. So it supports both as well, okay, as it is with the application load balancer. Okay, I hope I mean all the things are clear to you. Okay, please reach out to me if you have any doubts related to any of these points. Then the third one is gateway load balancer. So gateway load balancer enable you to deploy, scale and manage virtual appliances such as firewalls, intrusion detection and prevention systems. So frankly speaking, as I mentioned, I haven't used it in real time myself, but I mean from this definition itself, you can just imagine that it is used with some firewall, some intrusion detection and prevention systems. Okay, the features of it is it is based on layer 3 of the OSI model, which is called network layer. It listens for all IP packets across all ports and forwards traffic to the target group. Okay, that's specified in the listener rule. Then this classic load balancer. So classic load balancer, once again, it's a previous generation load balancer that is not used anymore. But let's just see the definition of it. So it also uses a listener, and it checks for connection requests from the client using protocol and port that you configure. So this is common in all of the 3 load balancers. Okay, application, network, and this classic load balancer, and forwards a request to one or more registered instances using the protocol and port number that you configure. So if you see here, it can only be used with registered instances and not with all other type of resources like containers or other things. Okay, so it can be used only with instances. You add one or more listeners to your load balancer. So you can add one or more listeners to load balancer. To a classic load balancer, you have the option to configure health checks, which are used to monitor the health of the registered instances, so that the load balancer only sends the request to its healthy instances. Okay, so it is like an application load balancer, but it only supports instances. It has no support for containers. Okay, and there are limitations to how it can be used. You cannot do path-based routing or host-based routing with this. Okay, so it's a very simple classic load. It's a very simple load balancer. And actually, before VPC, there was one more type of networking component or networking that was there in AWS, which was called EC2 Classic. So this classic load balancer were for EC2 Classic network only. Okay, so that is not used anymore. We use VPCs now, right? So that's why it is like the previous generation load balancer, which is not used anymore. Okay, then there's this URL which is really great. If you open it, you can check all the differences, and you can compare all these load balancers. Okay, to get a better view of it, you can view all the features of these different type of load balancers and check for yourself. Okay, so I would highly recommend to go through this once so that you understand the differences between all the load balancers. Okay, it has all the things that are there in a load balancer, all the features. All right, enough of the theory already. So let's head to AWS account and see how we actually can create a load balancer. This diagram, you can ignore this diagram. Okay, this is an earlier one. The diagram that I want to show you is this one. So this one, what I want to explain first, and then I'm going to create it in the AWS console. So let's see. So this is how a simple load balancer's architecture looks like. Okay, an application load balancer is a regional service, which means it resides within a region, within an AWS account. So consider this as AWS region. Within the region, you have 2 different availability zones. Okay, and you have created this load balancer in 2 availability zones, as you can see in the diagram. Okay, and it is always deployed in a subnet, either a public subnet or a private subnet. In this example, I am taking the examples of public subnets. So within the 2 different availability zones, you have 2 different public subnets, which are part of VPC, of course. As you can see, it is within a VPC, and you have created one application load balancer. Okay, so as from the definition, it's going to create 2 different nodes in those 2 availability zones, which you can see in the diagram also. So I've created this load balancer in 2 availability zones. Then AWS has created 2 different nodes which are going to serve the traffic there. Okay, and this application load balancer's incoming and outgoing traffic is controlled via a security group. Okay, so I'm going to show you a demo also after this, but I just want to explain the a very high level architecture of an application load balancer, how it is created. Okay, so this is how you create this application load balancer, which is created in 2 different availability zones. The incoming and outgoing traffic is controlled via a security group. Okay, then then it depends on the type of load balancer. If it's a public facing one, then it can utilize the internet gateway of your VPC, right, to have a connectivity from the outside world, okay, within the VPC. So this is how you can create one application load balancer, okay. A very basic one, you can say, because this is one of the basic architectures to understand the concepts. So let's just try to create this in our AWS account now. So here I'm logged into my AWS account, and the elastic load balancing service is part of EC2 only. Okay, so within EC2 service you will find this option. So this is my EC2 default dashboard, and you can see load balancers, auto scaling groups, instances, and some other resources as well. Okay, so let's click on this load balancers from here, or we can scroll from here also. This one, so it's the same thing. All right, so let's try to create one load balancer now. So click on create load balancer. It's going to give you the option which one do you want to create, application, network, gateway, or classic, which is the previous generation. So in my example, I'm going to create an application load balancer. So just choose this, click on create from here, then give it a name. Let's write demo load balancer. Then you get the scheme. You get to choose the scheme. As I mentioned, there are two types of load balancer. Either it can be internet facing, which means the external users on internet can access the load balancer, or it can be an internal one within a specified network. Okay, the private network. So let's use a default option here, and let it be the internet facing load balancer. Then what type of IP address do you want to use? Do you want to use IPv4 or IPv6? So in my case, I just want to use IPv4 IP address type. So let it be IPv4, because when you create a load balancer, it gets an IP address also. So if you've chosen internet facing, then it's going to assign a public IP address to it. Okay. And if you have chosen as the internal one, then it's only going to have one private IP address. Okay. So in case of internet facing, it's going to have both the IP addresses, the public and the private one. But in case of internal, it is only going to have a private IP address. Then, as I mentioned in the diagram, it is always deployed within the network, within the VPC. So here I just have this default VPC in this region. It's a regional service. So I'm logged into Northern Virginia region, which is US East 1. Within this region, I just have this one default VPC, which I'm using. And then I get to choose the options within the VPC in which subnet I want to deploy this load balancer. Okay. So as you can see here, at least 2 availability zones are required. Okay, 2 availability zones. Within the 2 availability zones, one subnet should be there at least. Okay, so that is how it is going to balance the load, right? It should have at least 2 different nodes which it can use to balance the node. So that's why we need at least 2 availability zones. Within those 2 availability zones, we should have one subnet. Okay, so let's choose US East 1A, and within this there's one subnet which is already there, and I'm going to choose US East 1B. Within this also you have another subnet. Then if I scroll down, if you remember from this particular diagram, so the incoming and outgoing traffic from an application load balancer is controlled by a security group. So you get the option to choose the security group here. Okay, so let's see which security group we want to use. So let's use the default security group, the default one from the VPC. Then scroll down, and here you get to choose your listener protocol and port, as we just studied, right? So here you can choose what protocol and port will be used to route the traffic to the target group. The target group will be the group of machines or the instances that is running your main application. Okay, so for that you have to create a you have to create a target group. So just click on this create target group option. It's going to open in a new tab. And here you get to choose what type of target group you want to create: instances, IP address, lambda function, or application load balancer, another ALB. In this case, I want to use instances, which is the default option. Okay, so if you have EC2 instances to be used as a target groups or as the target machines, then you can use instances option, which is the default one. Then you can put a name here, so I can write demo hyphen TG for target group. Then on which protocol and port you want to use, I just want to keep the same port as I've given in the listener section, HTTP port 80 that I want to use. Okay, here also it will be HTTP port 80. Then IP address type, I'm going to go with the default one, which is IPv4. And this target group again will be in the same VPC as my application load balancer. So it's going to be the default one. Within this, which protocol version I want to use. So I have the option to use HTTP2 and gRPC as well. But in my case, I'm going to use the default one, which is HTTP1. Then you get the option to choose the health check and health check path also. If you don't choose any path, it's going to be done on the root directory. Okay. So since we have not configured anything as of now, so let's just go with the default one. The health check protocol will be HTTP and it's going to be done on the root. Okay. Then under advanced health checks, you get the option to choose some more option if you have a different health check port. So there's an option to configure a customized health check as well for your applications, and you can specify a different port also. So if you have that type of requirement, then you can use this override option, and you get the option to change the port also of health checks that will be performed by the load balancer to the on the target machines. But in my case, I want to use the same port, which is port 80, the traffic port. The traffic port is port 80, as you can see here in the listener, it is HTTP port 80, and I want to use the same port as the health check port also. So I'm going to use the default option. Then how many? Then you can go through these different configurations. Okay, it's pretty simple actually. I don't want to go through these now, but if you have any doubts, please reach out to me. Okay, it is pretty simple to understand. So just go through these and try to understand. And if you have any doubts, please reach out to me. Okay, this interval time, which is of 30 seconds, I'm going to reduce it to 6 seconds so that I'm able to save some time to perform the health checks. Then success code, the default one is 200. Okay, so this is the default one universally for any successes. Any success code that you get from any application. So 200 is the default success code. So it is the same for our load balancer, and we are going to keep it the same. Then you can add some tags if you want to. Okay, but I'm going to leave it as default, and I'm going to hit next. And here I get to choose within my target group what targets should be there. Okay, so either you can use an auto scaling group also, but in my case I have two individual EC2 instances and I want to add both as part of my target group. So these will be the main machines which will be hosting my application, which will be used with my load balancer. Okay, so just choose these and then click on this include as this pending below, and also the default port is 80, which I want to use because I'm using 80 everywhere. If you see under my listener configuration of the load balancer, I'm using HTTP port 80. Under my target group also I have used 80. So here also I will use this port 80 only, and then click on include as pending below, and then click on create target group. So the target group is created. Okay, so there are two targets within this target group. All right, now I'm going to create my load balancer. So now if you just hit this refresh button, you will see the target group reflecting here to be added in the load balancer. So from here you can use this to choose the target group. Then you can add some tags to your listener. It's optional, so let's leave it as default. Then you can add some load balancer tags also. Then you have the option to integrate this load balancer service with other services like CloudFront or web application firewall. And there are some other new features as well. You can explore it. Okay, but I'm going to go with the default options for this video. So let's just leave it as it is and just review everything, whatever you have chosen. If you are satisfied, then click on create load balancer. So this is how you create a load balancer. And if you see this diagram, I have used the same things. Okay, whatever I mentioned here, I am using the same architectural diagram to create this load balancer. So try to match it with this. Okay, once again, if you have any doubts understanding this architectural diagram or how I created this load balancer with all the different options, please reach out to me in the comment section. All right, it's going to take some time to be provisioned. Okay, let's just refresh it. And so let's just see what all details are there till it's getting created. So this is an application type of load balancer. It is internet facing, which means the users will be able to access it from internet. It is deployed or it is created in this VPC. Within this VPC, I have chosen 2 availability zones in which a load balancer node will be created in these 2 availability zones by default. All right. This is the creation time and I'm using IPv4 address type. Pretty simple. Then I have this one listener and I have one default rule. So this is the rule that I was talking about within the application load balancer. If you click on this, you get the option to add multiple rules here. If you see here, so if you don't get any other rule, the default rule which is created will be used, but you have the option to create multiple rules for other things like path-based routing or host-based routing. So you can do all that. You get the option to have some other attributes as well. You can edit the attributes. Okay. This is rules. And here you get this information of your listener. Okay. We're using HTTP port 80. Name of the load balancer. Yeah. So let's go back to our load balancer now and see. Okay. It's still getting provisioned. It's going to take a moment or two to be ready so that we can start looking at it and see how we can actually use it with our real applications to serve traffic. Okay, so till the time it's getting created, let me head back to EC2 instances section. You can navigate from EC2 instances from this, open it in a new tab. So here I'm using 2 instances. Okay, and these 2 instances are using Amazon Linux AMI. Amazon Linux AMI. Okay, and it is also using a security group. So as you can see in this security group, I've allowed port 80. Okay, so actually I created this security group just before this demo. Okay, so you have to ensure, since we are forwarding the traffic from the load balancer to these target machines on port 80. Okay, so you have to ensure that you are allowing port 80 on this security group attached to the instances also. Else you will, the traffic routing will fail. So just ensure that you have added this port 80. Okay. Here I've used this source anywhere, but in real time you will have this, a very restrictive source. But since it's only a demo, so I've used this 0.0.0/0. Okay, and yeah, and let's head back to our load balancer section and see. It's still getting provisioned. Okay, it's active now. So our load balancer has been provisioned, Okay, now let's click on it again and see the details. So a load balancer is always accessed via a DNS name. So this is the DNS name. It is a record. Okay, so a load balancer is always accessed via a record DNS name. This is the one. So let's see if we are able to access it. So just copy it, and I'm going to open a new window in incognito mode so that there's no cache in the browser. Okay. Okay, so so of course it's not going to work because we haven't configured anything. Okay, I mean, why I'm saying it. So let's go step by step. So let's go to our load balancer and see the health checks first, because if you remember, the load balancer is going to perform health checks on all the registered targets, and it's going to route the traffic only to healthy targets. So if there are no healthy targets, then no traffic will be routed to this load balancer, which means that I mean, you cannot access anything on this DNS name of the load balancer since there are no healthy targets. So let's see the details. So the health of the targets will be available under the target group section. So under target groups, you have to see the targets here. It is being attached. Okay, and then you have to check the health checks. Sorry, I mean, health check is where you configure the health check, but under targets you get to see the health status. So as you can see, both our targets are unhealthy. Both our targets are unhealthy, and that is why we are unable to see anything on this page. Okay, if I try to access that again, it's going to fail. This is because bad gateway. Okay, so on the load balancer, we have configured HTTP port 80 to be used, okay, to route the traffic to the servers. Okay, so from here to the target machines, this port 80 should be open, and I mean, we have already checked that port 80 is open on this machine, and if we see this machine also, security group, port 80 is open to all. Port 80 is open to all, which means our security group configuration is absolutely fine. Okay, for the instances, and let's check for the load balancer also. So if you see in the diagram here, these EC2 instances also use a security group to control inbound and outbound traffic. This load balancer also has this security group attached to it. Okay, I mean, it can be the same security group or it can be a separate one. It can be an different security group as well. Okay, so we just check the security group of our EC2 instances. Okay, so all the things are correct there. I mean, we have all the open ports that we need on these two EC2 instances, but we haven't checked the security group of the load balancer, because from this user's point of view, this port 80 should be opened, okay, on the inbound of this application load balancer security group. So we have to verify that. So if I go to load balancer section here, if I go to security, I can see the attached load balancer, and if I click on it, let me open it in a new window, and we are going to see if port 80 is open on this default or not. Yeah, I don't remember if I've added it, not sure, maybe I did. Okay, so it is allowing all the traffic, which means port 80 is also allowed. Inbound and outbound, both, all the traffic is allowed. So all the things are correct as far as the security group of the load balancer is concerned. The security group of the EC2 instances is concerned, right? And we are using this default VPC of the AWS account. Okay, so which means that internet gateway and all the other things are also taken care of, because the default gateway has the internet connectivity, so we don't have to worry about that also. Then why we are not able to see anything on the page? This is because we haven't configured port 80 on the actual machine, on the actual VM. So there's nothing running on that VM on port 80 right now. We have to configure one service which is in running status on our target machines also. Okay, only in that case we can see something, because Right now there's nothing running on the machines, on the servers itself, on the targets, okay, on the EC2 instances. So we have to configure a web service that is running on port 80 there. Only then we'll be able to see something on the DNS of the load balancer also. So let's do that. So how we are going to do it? Let me log into each of these instances one by one. So let's choose the first one, which is this one, and click on connect. And I'm going to copy this example command, and I'm going to use mobaxterm terminal to log into this machine. All right. Anytime now. All right. So I'm logged into this machine now, and so there's a command to check the ports on which this machine is listening on. So the command is netstat space hyphen TULNP, and then you can use this pipe symbol to grep for listening port. So right now, as you can see, this machine is not listening on port 80. Okay, so there's no port 80. There's port 22, port 111, port 25, but there's no port 80. Okay, so let's install one web service. The most basic one is Apache web server, or HTTPD. So since I'm using Amazon Linux, I can use this command yum install. Let me become root. So I'm going to become root on this machine. Sorry. And now I'm going to install Apache web server. So I'll do yum install httpd -y. So web service is installed. Now I have to configure it and start the service. So the most basic way to start an Apache web service is you can echo some random text like server 1, and on Apache web server, the default directory, or the default the default file that is served is under /var/www/html. Name of the file is index.html. So what I'm trying to do is I'm pasting some random text in this file so that I can serve it on the default page of the website. Done. Then I'm going to do systemctl to start the service. So I can use systemctl start httpd. Okay, I can check the status also. Systemctl status httpd to check the status of the service httpd. httpd is also called Apache. Okay, remember this. So the service is running. Now if I run that same command again, I can see it is listening on port 80 as well now. Okay, so let's go back to our server here, server DNS, and just try to refresh. Or maybe before that, let's check the health check of the target. So let's go to target group, under targets. Okay, hit refresh. And you can see one healthy, one unhealthy. Here also you can see one healthy, one unhealthy. So as soon as I configured a web service listening on port 80 on my target machine, the health status became healthy, which means that now the load balancer has one target is healthy, but the other one is still unhealthy. So the traffic will not be routed to this machine, only to this machine it will be routed. So let's see it in action. So if I just hit refresh here, server 1. So if you see, I mean, whatever I pasted in this machine, I pasted this text server 1 in the default file where which is I mean served by HTTPD, and when I hit refresh, I'm able to see this machine. So which means that I'm able to, I mean, get the response back from the server using the load balancer. Okay, so if I hit refresh n number of times, it's only going to show me server 1 because only server 1 is healthy right now. So server 2 is unhealthy and the traffic will not be routed to that. So I'm the user here. Okay, I'm the user. I'm trying to access this load balancer's DNS on public internet from my laptop, and I'm able to access it. But I'm able to access it only on server 1 because only server 1 is healthy right now. Server 2 is still unhealthy. So if I configure server 2 also, let's do that. If I log into server 2 and try to configure the same service, so then I'm going to see the round robin way of sending the traffic from the load balancer to the target machines. Okay, so let's log into other machine. Let's go to instances, and I'll choose the other machine this time, and I'll configure the web service in the same way, and then I'm going to see the response of the load balancer if it's able to serve the traffic on the two machines in a round robin fashion or not. So I'll choose the other machine, click on connect, choose the example command, go to my mobile XTerm terminal and log in. I hope guys the concepts are getting clear to you, how we actually use a load balancer to serve the traffic on our EC2 machines for a real application. Okay, but I mean, I'm using a very simple application, but it can be any application, but the method or the concepts are going to remain the same. Okay, so I'll become root now and I will install Apache. Done. And I'm going to echo some text, and this time I'm going to echo server 2, and it's going to be directed to the same directory which is served server 2, and I'm going to start the service. So systemctl start HTTPD. All right, let's check the status. It should be running. It's running now. So now if I check the status of the health check of the other server, refresh, you can see 2 healthy now. Okay, so I mean both our servers are in healthy status now, which means that I mean both the machines can serve traffic since we're using application load balancer, and the default algorithm is round robin, which means one request will go to this server, the other request will go to this server, the third request will go to this server, the fourth request will go to this server, and so on. So this is called round robin algorithm. So let's see it in action. Hit refresh. Server 2, if I hit refresh again, server 1, if I hit refresh again, server 2, server 1, server 2, server 1. So this means that we have been able to deploy a load balancer to serve the traffic on our 2 target instances. The 2 instances are running a web service, Apache web service on port 80, and it is using round robin algorithm, and both the servers are in healthy status. Okay, so our demo was successful. I hope the concepts were clear to you, how the traffic is flowing. If I just show you in the diagram also once here. So from the load balancer, I mean, I'm the user, I'm trying to access this load balancer using its DNS name. Okay, it performs the health check on both the servers. The health checks were successful, were healthy, so it's able to route the traffic. Okay, on the machine we have just configured this web service on port 80, and we are able to serve the traffic on port 80 using this load balancer. So the traffic is flowing from the user's internet to ALB, and from ALB to the server, and within the server to the application service running on port 80. So this is how the traffic is flowing. Okay. So that's all I wanted to cover in this video. I think the video turned out to be really long, but I think it was I believe it was beneficial to you guys. All right, guys. So I hope it was useful to you. If it was, then please hit the like button. Okay, and please share it with your friends and subscribe to my channel. Okay, so that I'm motivated enough to make more videos like this. And if you have any feedback, any questions, please reach out to me in comment section. I'll be glad to assist you. Alright guys, that's all for this video, and I'm going to see you in the next one. Bye.